It's in the final project. So.
Good morning. Okay, so today's topic, we will go to the complex numbers. Before we start our topic, are you ready? Okay, so complex numbers, you will find this in Appendix A. Basically, today's lecture will be a math. It's a review about the complex numbers overall in math. So what does complex numbers mean, and how we can convert between the forms of complex numbers like polar, rectangular, etc. So you will realize that the complex numbers are very important, and we will use them a lot in AC circuits. So you need to make sure that you have a calculator that can support the complex numbers. So let's start a little bit about the numbers, then we will talk more about the calculator and other analysis. So again, today's lecture is just a math. Numbers, as we know, the numbers can be either real numbers or complex numbers. This is from math. So when I say real number, what do I mean by real number? Any number that we know in real life, right? It can be either 1, 2, integers, or it can be like 0, -1, -2, negative numbers, or it can be a fraction, 1/2, 1/3. It can be also like rational numbers or irrational numbers like pi, square root of 2, e power 1. So all of them are real numbers. So any number that we know that only has one component, it will be considered as a real number. So basically, it can be considered as one-dimensional number. So if you draw a line, you can say here is the location of 0, this is the location of 1, location of -1, 2, 3, 4, etc. And you can say, for example, pi, it can be somewhere between 3/4, right? And you can say 1/square root of 2, it can be something between 0/1, 0 and 1. Because 1/square root of 2 is 0.79 something. Then even if we don't know the exact value, but we can put it in one-dimensional line. So any number that have one component is considered as real number, and it can be only in one dimension. Okay? While complex numbers, which will be most likely two-dimensional complex plan. Basically, there will be x component and y component, or if you can make it in the xy plane, so it can be x components and y components. Or in other words, I will mention x as real parts. This is imaginary parts. Okay? So that's from math. Any number that will be written into two components, like there's x-axis and y-axis, it will be considered as complex number. So, for example, if I locate a point here, it can be, for example, between, here is 2, here is, we call it j or I2, something like that. Or we can say like here is 2. So you will say in the x-axis is 2, y-axis is 2. So if we need to represent this, we can represent it as 2 plus 2i, such that I will be associated with the y-axis or imaginary parts, while 2 will be associated with the real parts. So basically, it will be on xy plane. Therefore, it is complex numbers. Okay? So in complex numbers, as we know in calculus, I think calculus 2, which is there is a rectangular coordination, there is a polar or polar format, rectangular format or polar format. So this means whenever I have a point in the xy plane mode, no matter what it is, if it's not about only complex numbers, it can be about any coordinations in xy plane mode. So we can say, for example, that's a vector go to this point, then there is an angle theta. So if we want to make it in polar coordination, it will look like a circle, and that arrow is moving in the circle. That arrow radius can be changing, or the theta can be changing. So that's how it looks like for the polar form. While the rectangular form, it is go to the x-axis and y-axis. So I think you need to be familiar with the polar formats, where it's like this. Or rectangular formats, where it's like this. And how to make the conversion between polar to rectangular. Okay? So that's basically the complex numbers. We realize that it can be represented into two parts or into two representations. We have one representation into rectangular formats. We have one representation into polar formats. Okay? Now, let's discuss this equation. We have z squared minus 6z plus 25 equal to 0. Now we need to calculate or to find the roots of this one, roots of this equation. So let's try to find the roots. Basically, this will equal to 0. Then, in order to find this, we can say the general formula for the quadratic equation az squared plus bz plus c equals to 0. Then, in order to find z, we can use the general formula to find the root for the quadratic equation, which is negative b over 2a plus minus the distinguished, which is b squared minus 4ac. Now you know this from math, which is the roots of the quadratic equation. So again, like here it is 2 times a. Okay. Then we can substitute them. We have b as negative 6, c is 25, a is 1. So it will be as negative 6 plus minus square root of negative 6 squared minus 4 times a, which is 1, times c, which is 25. Divided by 2 times a, 2 times 1. Then after that, this will yield to 6 plus minus square root of 36 minus 100 divided by 2. So the overall answer will be negative 6 plus minus square root of negative 64 over 2. Now, here is the point about the complex numbers. So we have a square root of negative 64. In old math, before we learned the complex numbers, we used to say we cannot say a square root of negative number. But then in calculus, maybe calculus 2 or calculus 3, then when you learn about the complex numbers, then we say, okay, we can define the square root of negative number. How we can do it? Basically, you can say it is negative 6 plus minus square root of negative 1 times square root of 64 over 2. Then square root of 64, which is 8. So it will be negative 6 divided by 2 plus minus square root of negative 1 times 8 divided by 2. Okay? Then divide by 2, negative 3 plus minus square root of negative 1 times 4. Then we define the square root of negative 1 as the imaginary number, which is I. Something does not exist, but we define it as imaginary number. Then it will be as negative 3 plus minus 4i. Okay? That's how we represent it. Therefore, we can say we have actually 2 points, which is negative 3 plus 4i, then negative 3 minus 4i. Because as we know, the quadratic equation must have 2 roots. Then these 2 roots can be plus and minus, which is different in the imaginary part, while the real part will be the same. Okay. Then, that's in math. In electrical engineering, we will use something similar to this. But actually, we used to use this I symbol, right? And what's I stands for what? Current, right? Now, if we need to use this in electrical engineering, we will get confused. Is I for the current or is I for the complex or for the imaginary number? Therefore, we decided to replace I by J in order to avoid this confusion. So in electrical engineering, we will call replace I by J, so it will be as -3 plus minus J4. That's what we will use. So J is the same as I. When you do it for the calculator, you need to insert I. But when you do it, solve for electrical engineering problems, you need to replace I by J. Okay? Again, this is to avoid the confusion between the currents and the imaginary number J. Imaginary number I. So we use J. So if we need to represent this into the form which is the XY plots, here is 3 plus J4. And if we need to expand it to find the other roots, which is 3 minus J4, which will be located here. Okay? So these are the locations of two poles, or I'm sorry, two roots of this quadratic equation. Now, you see that 3 plus J4, this is actually written in a format called rectangular format. Rectangular form. Rectangular form where is real part, imaginary part, or X component, Y components. It's not written as angle or magnitude. Then we need to know how to convert this into something we call it the polar format. So the polar format, basically, let's choose the upper parts. Here is the angle, it's called angle theta, and this is Z. So how to find Z and theta? Basically, you can say the x-axis component is 3, the y component is 4, then Z is the hypotenuse, then the hypotenuse using, we can use it by saying like Z equals square root of x squared plus y squared, which is square root of 3 squared plus 4 squared, so it's going to be as 5. Because we know the hypotenuse square equal to the adjacent square plus the opposite square. Okay, we know this here. Then that's how we find Z. Then the other thing, which is to find the angle theta, you can use the cosine, or actually you can use the tan. The tan is the opposite over the adjacent. So we can say tan theta equals to y over x. So in order to find theta, it will be tan inverse of y over x, or in other words, equal to tan inverse of y here, 4 over x3, then it will be as 53.13 degrees. That's theta, the angle. Again, this is a math, so we should know how to convert between rectangular to polar and polar to rectangular coordinates. So in other words, I'm going to say that whenever we have a complex number Z, it is 3 plus J4, this is in rectangular coordinates. If I need to do it in polar coordinates, it will be the magnitude 5, angle 53.13 degrees. So the first one in rectangular, the second one is in polar. Okay? So that's how we do the conversion. Now, let's try to make some standards for electrical engineering, so we can sometimes, to make our answers based on our standards, it can be sometimes different than calculus, or different than what you learn from math, which is based on the notation. Like when we replace I by J, so our notation in electrical engineering is J. Now there is some other notation. So most likely in math books, they used to write the complex number as a Z in bold. That's most in many math books. While in electrical engineering, or sometimes when you do it in handwriting, it's hard to make it as bold, or sometimes it can be not easy for us. So therefore, in electrical engineering, we use Z bar. So we will put bar above the complex quantities. Then we can know this quantity is complex numbers or not by looking at the bar. If there is no bar, then this number is not complex. It's not complex. Okay? So it's a must starting from now. Any complex number or complex quantity, you need to put a bar on it above this symbol. Then in the this is the rectangular formats in the common or in the math. This is our rectangular format. So we'll replace I by J. No matter if it was I, we'll need to use J. Then we have the polar formats. Sometimes it can be drawing in exponential form. It can be drawing in the other form. So what's the difference between the exponential form and the they are both polar form and the other form. Basically, you will see the angle here in degrees, while in the exponential form, the angle here in radians. So depending on which reference you prefer. What we will use this in this course, which is when the angle degrees. We will use this one, which is the rectangular, when the angle in degrees. So you can guarantee, make sure your calculator is being adjusted in degrees, then everything's fine. You don't need to worry about the radian. But here, for your information, if we wrote it as polar form, so we can say here is z bar x plus jy, or it can be as z as a magnitude angle theta, or it can be here theta in degrees, or it can be z exponential j theta in radian. Okay? How to find theta radian to convert radian to degrees and vice versa. So theta radian equals theta degrees times pi over 180 degrees. Okay? That's the conversion if you need it. Okay, clear? Then, since we have z equal x plus jy, so z bar, I'm going to write it here again.
Over to the m gets there.
X plus jy, which is z angle theta. Every quantity we will call it with its own name. So z bar with the bar, this means a complex number, the complex number. Z without bar, like this one, it will be the magnitude alone. So when you see a symbol without bar, this is a real number, which is basically the magnitude. Then theta is the angle, and most likely we'll use it in degrees. Okay, what else? X is the real parts. Y is the imaginary parts. Okay? Now, the convergence between rectangular to polar, basically, as I mentioned before, which is z equal the square root of x squared plus y squared. Then theta equal the tan inverse of y over x. How about if I need to make the opposite polar to rectangular? You will say x equals z cosine theta, y equals z sine theta. Basically, you can imagine that you have this theta, this z, here is x, here is y. Then you can make the projection of z on the x-axis, so it will be x equal to z cosine theta. The projection of z on the y-axis, so y will be z sine theta. That's how we find this. And if you need to find z, basically, it will be the square root of the opposites, x squared plus the adjacent square. That's how we do it. And theta equal to the tan inverse of y over x. Okay? So yeah, it's easy. Let's look at an example. Find the polar form of 10 minus j5. So basically, this is, since it's in rectangular, this is equal to x plus jy. So we know that x here equal 10, y equal to negative 5. So in order to find z, it will be the square root of x squared plus y squared, which is the square root of 10 squared plus negative 5 squared. Since negative 5 squared is negative 5, when we make square, the negative sign will cancel each other. So 25 plus 100, it will be 125. The square root of 125 will equal around 11.18. Now theta, it's actually the tan inverse of y over x. So y here is negative 5, so it will be tan inverse of negative 5 over x10. So since there's a negative, it will not be removed. So keep in mind to put the negative sign inside the tan. So the answer will be, when you do the tan inverse, negative 26.57 degrees. Now I'm not done yet. I need to write this in the general formula, in the general polar formula, which is z angle theta, which is 11.18, angle theta, which is negative 26.57 degrees. This is actually z angle theta. That's how we do the manipulation. Okay. Then the other thing, which is we need to convert polar to rectangular form. So here the polar, basically it's looked like z angle theta. We need to convert this to be x plus jy. So we have z as 13. We have theta as negative 67.4 degrees. How to find x? Basically x is the projection of z bar on the x-axis. So it will be as z cosine theta, which is 13 cosine negative 67.4 degrees. So the answer will be 5. Then y will be z sine theta, which is 13 sine negative 67.4 degrees. So it will be negative 12. So keep in mind, cosine is even function, so therefore the cosine of negative angle will be positive, while the sine is odd function, so sine will be, the sine of negative angle will be negative number. So x z bar will be x plus jy, which is 5, then y is negative j12. And that's it. Okay, does this make sense? Now, we will not stop here just making conversion between polar and rectangular, but we will do something, we call it arithmetic analysis on the complex numbers. Arithmetic analysis like what? What does arithmetic analysis mean? Addition, subtraction, multiplication, and division, right? So how can we do this with the complex numbers? Okay, let's go and see. So basically here, let's assume that the complex quantity A, this is the rectangular format, this is the polar, B the same, this is rectangular, this is the polar. Now we need to do addition. In order to do addition and subtraction, actually, the best thing to do it, you need to convert this or use rectangular form. Use rectangular form. You cannot do the subtraction or addition whenever you have polar. So it will be a bar plus b bar. Convert this to rectangular form. Then the real part sums together, the imaginary part sums together. While for the subtraction, convert this to rectangular form, then subtract the real parts together, subtract the imaginary parts together. And that's it. So keep in mind, just do this for the real part, do them for the imaginary parts. While if it is in polar, you cannot do this manually. Okay, so you need to convert this to rectangular. However, whenever we have multiplication and division, the best thing is to use polar form. So when you use polar form, it will make the life much easier. So how? Whenever there is a multiplication, use the polar form. So there is A and B. Multiply the magnitudes, while the angle, you will add them. Addition. The angle will be, there will be addition. While for division, divide the magnitudes and subtract the angles. Okay? That's it. So the best thing, whenever we deal with any complex numbers quantities, I have multiplication and or division, multiplication and division, convert everything to polar. I have addition and subtraction, convert everything to rectangular.
And that's it.
Now there is also a new thing that's, I think you might be familiar from this in complex numbers, but whatever. So here there's something we call it complex conjugates. And we will use this a lot, especially in the power in AC. So conjugates means we will replace that by a star above that quantity. So the conjugate means put a negative sign of the angle or negative sign of the imaginary part. Or actually flip the sign. Not only, I mean flip the sign. So for example, if I have A bar equal 3 plus J4, so A bar conjugate equals to 3 minus J4. Assuming I have B equal 5 angle negative 30 degrees, then B conjugate equals to 5 angle negative negative will make it positive 30 degrees. So that's the point. So the conjugates means flip the sign. Either if you have in polar format, flip the sign of the angle. If you have the rectangular coordination, flip the sign of the imaginary parts. Okay, is this clear? Okay. So here, like, I'm going fast because I'm assuming we already know this. So here, and just I'm reminding you about this. So just like a review. Now, let's go do some examples for practicing, like how to do polar to rectangular, rectangular to polar, how to do some arithmetic analysis. So the first one, 3 plus J4 plus 10 minus 2 minus J1. Okay, how can we solve these to find this? Basically, it is addition and subtraction. There is no multiplication or division, the first one. So the best thing is to make sure everything in in rectangular coordinates. Yes, everything in rectangular. Then look at the imaginary or real parts, 10, 3, 10, and negative 2. 3 plus 10, 12, minus 2, 11. So we will put here 11. Then the other thing we have J4, negative J1. J4 minus J1 will be J3. So it will be plus J3. This is in rectangular coordinates. Let's assume we need to convert this to polar coordinates. So in polar coordinates, it will be the square root of 11 square plus 3 square angle of tan inverse of 3 over 11. Then it will be as 11 points for angle 15.26 degrees. Okay? That's it. So just like some arithmetic analysis again, like addition, subtraction. The next one, it is subtraction, but the thing is, this expression, the problem is everything in polar. And according to our procedure, in order to do subtraction or addition, then we need to convert everything to be rectangular coordinates. So let's convert this to rectangular coordinates. The first number, I encourage you when you convert this to put the brackets. It is 2 cosine negative 45 degrees plus J2 sine negative 45 degrees. Then this is the first number, negative, minus. Then put a bracket, 6 cosine 100 degrees plus J6 sine 100 degrees. So let's do find the values. So it will be the first one. It will be as 1.414 minus J1.414. Then subtract it from negative 1.042 plus J5.909. Now, when you do the subtraction, do it for the real parts together. Don't forget there is a subtraction. So 1.414 minus negative, minus will make it positive. So the answer will be, for the real parts, as 2.456 because it will be converted to addition. Then minus J 1.414 minus, for the second one. Then there is a minus here. There is a positive. So it will be negative. So it will be negative J. Then 1.414 plus 5.909. This will make it as 7.323. That's in rectangular coordinates. If we need to convert this to polar, it will be as square root of 2.456 square plus 7.323 square angle tan inverse of negative 7.323 divided by 2.456. So the answer will be 7.72 angle negative 71.46 degrees. that. Okay? So you see that analysis? That's how we do it. Now the last one, 5 angle negative 110 divided by 10 minus J4, 10 angle 15. So we see it's multiplication and division. So the best thing is to make sure everything is polar. It's almost everything in polar except this expression. We need to convert this to polar. So after converting this to polar, it will be 5 angle negative 110 degrees divided by, this will be 10.77 angle negative 21.8 degrees times 10.15. Now after converting this to polar, I'm ready to do the multiplication and division. So we just convert this to polar. Let's do the division, basically multiplication and division. Let's group the real parts together and imaginary parts together. So it will be, and the angles together, the magnitudes and the angle. It will be 5 divided by, here I missed the angle, 10 angles. It will be 5 divided by 10.77 times 10. Then the angle will be negative 110 degrees, then subtract of negative 21.8 plus 15. That's how we do the angles. So the overall answer, after making this analysis, will be as 0.046 angle negative 103.2 degrees. This is in rectangular coordinate. If you need to convert this to polar, just apply the formula. We will end up having 0.011 minus j 0.045. That's how we can do it after doing the conversion. Okay? Is this clear? Yes.
I was just wondering if there was a reason why J was in front of the imaginary part, or is that just like convention?
Yeah, so yeah, in our electrical engineering analysis, we used to put J before the number. Yeah, I didn't like why the reason, but that's our analysis. While in math, it will be like, for example, 3 plus 4i, while electrical engineering 3 plus J4, yes. I don't know actually the reason, but that's the notation. So J will come first. Okay. Any other questions? Okay, now the next thing is I need to discuss about the calculator. So you see this analysis, addition and multiplication might take long. And sometimes when you solve this, as you will see this later in the AC circuits, you will do this addition and subtraction or multiplication and division a lot. You will do this maybe 3 or 4 times to solve one circuit or one problem. So it will be time consuming. So do I really need to make this conversion every time? And do this cosine, sine, tan inverse, and the projection? The answer is no, you don't need, because the calculator now, we have that facility that calculator that can do the whole job. So I'm going to explain one of the calculators, which is called Casio, FX11FE. While if you have the TI calculator, it can be a slide different. So basically, in this calculator, okay, so in this calculator, you need to enable the complex number. So basically, you need to make sure there is a complex mode here. Most likely the mode is like this. This is the default case. So we will go shift mode. I'm sorry, without shift mode. I go on without shift. So you'll go complex. Press number 2. Now complex mode is being activated, and keep in mind degrees. So it's complex and degrees. Then, if I need to enter the number in rectangular coordinates, so here is the simple I. It's located here. This is the simple I. So let me insert 3 plus J5. 3 plus J5 shift I times 5. Then this is the number that's it's been converted into polar. This is the default of this calculator to be polar. However, I need to convert this back to rectangular coordinates. If I need to convert to rectangular coordinates, you will see another option here is called complex at number 2. So we will press shift, complex, then you will see these options. So option number 2, convert this to polar. Option number 4, convert this to rectangular. So I'm going to press 4. Here is rectangular. Then 3 plus 5i. That's how the calculator, I mean, we are in math, we call it I, not J. Then that's how we wrote the numbers. Let me say, like, I'm going to insert polar format. Like 5, I need to put the angle. The angle symbol is here. Shown here. So you will press shift and the angle symbol. Then the default is degrees, so I'm going to put 30 degrees. Then equal to this one and 5 angle 30. I need to convert this to polar, rectangular, shift angle complex, then it will convert. Number 4, it is rectangular, then put this to get the value. That's how we convert these numbers into polar to rectangular coordinates. Then the last thing, how to do the arithmetic analysis. Let me say I need to say 3 plus 5 j5 or j5 5 times I plus 30 angle 50 degrees divided by 2 angle 30 plus 2 minus I times 6. The good thing about the calculator, we mentioned about the arithmetic analysis. In order to have multiplication and division, we need to convert everything to polar. But here, we don't need to do anything. Just enter the number as is and put equal sign. The calculator will do the job. So the calculator is smart enough, so we don't need to make the conversion for the numbers. Just put the number as is. You don't need to convert for addition and subtraction to convert this to polar or to convert this to rectangular. You don't need to convert multiplication and division to polar. So the calculator can do the whole job. Okay? So that's a small demonstration about using this calculator. Then for other types of calculator, I encourage you to go to YouTube, see how to use the complex numbers. Please make sure your calculator is supporting the complex numbers. Otherwise, you will have a problem in the second, third, and the final exam. So that will be your homework during the weekend.